Hi guys, this is just a quick video on how to do the empirical formula or how to find the empirical formula. I'm just going to do questions 2 and 3 from the sheet that starts off like this up at the top, empirical formula worksheet. Um, Make sure that you pay special attention to this definition. And if you get lost at any point in time, here are your 3 steps in sentence form. And then also here are your 3 steps listed out for you. With a diagram with a real example problem. Okay, so I'm going to be doing questions 2 and 3. Question number 2 says, find the empirical formula of a compound that contains 53.70% iron and 46.30% sulfur. The way that I got those percentages was they took a 100-gram sample and decided or analyzed it and figured out what percentage of it was iron and what percentage of it was sulfur. And because they did that in a percentage form and they took it out of 100 grams, then we can literally translate those percentages to be grams. So in the problem, it gives us 53.70% iron. So that is signaling to me that it's 53.70 grams. So I always start out listing what element I'm talking about. I'm talking about iron. Iron's symbol is Fe. Fe is a transition metal, and it's right there in the middle of your periodic table. But Fe was given to us, and it had 53.70 grams. Well, step 1 is that we have to convert out of grams and into moles. So we're going to do a simple T-chart because the word convert tells us to go. Okay? I know that grams has to go on the bottom because it's on the top and we eventually want it to cancel out. And I know that I'm converting into moles. And for this unit, always and forever, the number that goes with moles is 1. To find the G, any G that you need to use the periodic table. So we're going to go to the periodic table for that. And we're going to get the atomic mass of iron. And that says 55.85. So I'm going to put 55.85 right in front of here. Empirical formulas really don't have anything to do with particle numbers or any types of atoms, molecules, ions, formula units. So we know that we're not using Avogadro's number. Notice we're not using that. Same setup as before. You multiply across the numbers on the top. You divide by the numbers on the bottom. And we punch that simple calculation into our calculator. So 53.70 divided by 55.85 comes out to be 0.96. And the third number is a 1, so that's less than 5, so that tells us that we keep it at 0.96. So now we'll do the exact same thing for the second element in this. The second element in this is sulfur. I know sulfur's symbol speed S. I'm going to pick out the grams that it gave me in the problem, and the grams that it gave me in the problem, it says 46.30%, but remember that the percentage means grams to us. So I'm going to copy it down, and I'm going to go ahead and convert into moles the same way I did for iron. 1 still going with the moles. Grams, still looking them up on the periodic table. There's sulfur, 32.07. Still doing the same, cross out, because they're the same on the top and the bottom. Multiply the numbers across the top. That happens to be 4630. Divide by 32.07. And you'll get, well, let's plug in the calculator, 46.30 divided by. That equals to 1.44 moles. All right, the next step is this. You're going to be looking to see which mole number is smaller. So between these two, we notice that this one is smaller. But we're going to divide both numbers by the smaller mole number. So we're going to divide both numbers by 0.96. Any number divided by itself is 1. So I like to put mine down there in a circle. And then we're going to say, okay, 1.44 divided by 0.96, and we see that it gives us a flat 1.5. But remember, empirical formulas are the ones that have the simplest whole number ratios, and we don't have a whole number right here. So we are going to have to multiply this one by a number to turn it into a whole number. Well, you take a look at what the decimal number is. The decimal number, regardless of this number in front, is 0.5. Anytime we see some number, 0.5, could be 1.5, 4.5, 5.5, any of those numbers, you have to turn it into a whole number by multiplying it by 2. That multiplication of by 2 against the 0.5 turns that into a 1, and so on and so forth. So if you plug that in your calculator, you'll get that this is 3. And just like in math, and then we squiggle out because that's the old and we want the new. Okay? And then if you'll notice that it, just like in math class, whatever you do to one side, you have to do to the other. Well, that's the same thing for empirical formulas and elements. Whatever you do to one element, you're going to have to do to the other. So if I multiply this one by 2, I'm going to have to multiply this one by 2. And then 1 times 2 is 2. New, we keep. Old, we mark out. And the very last step is to write your chemical formula. Remember that chemical formulas always have letters that go first. So my first set of letters is Fe. Whatever number you've circled and put down here becomes a subscript, so that's 2. You're going to do your letters of S, and then you're going to put whatever number you circled, which is 3, as a subscript. You're going to box it in, and that's it for number 2. Now let's check out number 3. Okay? Number 3 reads, analysis of a 10.150 gram sample of a compound known to contain only phosphorus and oxygen indicates a phosphorus content of 4.433. What is the empirical formula of the compound? Well, the first thing I notice is that it tells me a total mass of 10.150 grams. And then it tells me a partial mass, which was for phosphorus, which is 4.433. But it doesn't tell me the grams for oxygen, but we can find that. So I'm going to say oxygen is equal to 10.150 minus 4.433. You plug that in the calculator and you get 5.717 grams of oxygen. So this is the grams of oxygen that you'll be working with when you go to convert it. So let's start with the first element listed in the problem. The first element listed is phosphorus. Phosphorus' symbol is P, so I'm going to put a P right there. I'm starting with 4.433 grams. 4.433 grams. I'm converting that into a mole. Grams has to go on the bottom because you want those to cancel out. I'm converting it into 1 moles. I find this G on the periodic table. Phosphorus is element 15, so that's a mass of 30.97. Cross out, across the top, multiply, divide by whatever's on the bottom. Plug that in the calculator. And you'll get this decimal number right here. So I'm going to take it to 2 decimal places. The 3 is less than 5, so that means I can leave it as 0.14. And the unit is moles. I'm going to do the exact same thing with oxygen. I'm going to take the calculated mass that we just found for oxygen, which was right here, and say 5.717 grams. I'm going to convert that into moles. So grams has to go on the bottom, 1 mole has to go on top. The grams from the periodic table, oxygen is 16.00. Cross out the same on the top and the bottom, and I'll end up with 5.717 divided by 16.00. And that, when I plug it into my calculator, is equal to 0.36. All right? Second step. Which of your moles numbers is smaller, 0.14 or 0.36? Well, we know that 0.14 is smaller than 0.36, so we're going to divide both of these by 0.14. Divided by 0.14 is 1. 0.36 divided by 0.14 is equal to 2.5 or 2.6. 2.6. We'll say it's 2.6. Or no, we'll say it's 2.5. My bad. Sorry. We'll say it's 2.5. I see that I have that 0.5 right there, and so we're going to do like we did before. To change a half into a whole number, you have to multiply it by its reciprocal, and that reciprocal of 0.5 is 2. So we'll multiply this by 2. 2.5 times 2 is 5. Squiggle out the old. What I do to one side, though, I've got to do to the other. So I'm going to say times 2. 1 times 2 is 2. Put that like that. And then right here, what you're going to do is squiggle out the old. Now we're going to smush together letter, number, letter, number. Okay? So it goes letter. This big 2 becomes a little 2 as a subscript. O, 5. Box it in, and now you're done. Now, your homework tonight is to do problems 5, 6, and 7 and turn that in. Remember that we're saving 8 and 9 for me to do with you guys during the bell ringer.